Hello students, in this video I am going to tell you about the empirical formula and the molecular formula, and the learning objectives of this video is 1. Compute the percentage composition of a compound. 2. Determine the empirical and molecular formula, and I am going to tell you about how to calculate the molar mass or formula weight, mass percentage composition, and how to determine empirical and molecular formula, and finally we'll have self-test activities. And let me move to the calculating the molar mass or formula weight. 1 for an element. The molar mass for an element is equals to the atomic mass, that is atomic mass number of that of element from the periodic table. Simply go to the periodic table and obtain the mass number. For example, the molar mass of the silver is 107.9 and for carbon is 12.01, and similarly do for the other elements. This is the molar mass for element. The molar mass for a compound is the sum of or the addition of individual atomic masses. Example, if you are asked to calculate the formula weight of the lithium carbonate, how can we calculate? And the formula weight of the lithium carbonate can be calculated in this way. Step 1 is obtain the molar mass of each element, that is from periodic table. Go to periodic table and obtain the molar mass of each element. The molar mass for lithium is 6.94. The molar mass for the carbon is 12.01, and for oxygen is 60. Step 2 is multiply each molar mass by the number of molecules or subscript. Here we have 2 for lithium, 1 for carbon, and 3 for oxygen. And then multiply the molar mass of lithium by its subscript, that is 2. Multiply the molar mass of carbon by its subscript or mole, that is 1. And multiply the molar mass of oxygen by its subscript to obtain the total molar mass of each element. Step 3 is calculate the molar mass by adding the masses of the elements. So if you add the mass of all elements in the compound, the molar mass of the lithium carbonate becomes 73.89 gram. This is example 1. Example 2 is calculate the molar mass for methanol. The molar mass for in the methanol compound, we have carbon, hydrogen, and oxygen, and the number of atoms in the methanol is 1 carbon, 2 hydrogen, and 1 oxygen, and the atomic weight for each element from the periodic table is this one. And then when you multiply the atomic weight by its number of atoms, the total molar mass for each atom becomes this. And finally, when you add up these masses of the elements, the formula weight becomes 30.03 atomic mass unit. This is the way of calculating the molar mass for an element and for a compound. Another thing is mass percent composition. How can you calculate the mass percent composition? 1, by using the given mass, you can use this formula to obtain the mass percentage from the given mass. Simply divide the given mass of each element by the given mass of the, this is not molar mass, but the given mass of the compound, and then multiply by 100. Example, if the given mass for nitrogen in the nitrogen dioxide is 7.64 gram, not molar mass, and the given mass of the dinitrogen oxide is 12 gram, not its molar mass, then the mass percent of nitrogen can be calculated as dividing the given mass of nitrogen by the given mass of the compound times 100, and we will get 63.7% of nitrogen, and the rest percentage is the mass percent for oxygen. This is example 1. Another is obtaining the mass percent from the molar mass. To do this, you can use this formula. The mass percentage of element is equals to the amount of, or in terms in mole of that element times the molar mass divided by the molar mass of the compound times 100%. Example, calculate the percentage of carbon, hydrogen, and oxygen in this compound, and analyze the problem. What's given? The compound is given, and we are asked to calculate the percentage of carbon, hydrogen, and oxygen. So we need to connect with the periodic table. The first step is determine the total mass of each element. The molar mass of the carbon from the periodic table is 12.01 and it has 5 moles. So multiply its molar mass by its mole. We will get this. For hydrogen, we do have 10 hydrogen moles here. Multiply 10 by its molar mass, we will obtain this. Then for oxygen, similarly, and then finally add up the moles, the molar mass of the components of the compound, and we will get 102.13 gram of the compound. Step 2 is divide the total mass of each element by the molar mass of the compound and multiply by 100. The mass percentage of carbon is equal to the mass of carbon divided by total molar mass of compound times 100, and we will get this. For hydrogen 9.870%, and for percentage of oxygen is equals to its molar mass divided by the molar mass of the compound times 100. We will get this amount. Note that the total mass of percentage of all the elements in the compound becomes 100%. This is how to calculate the percentage mass. Example 2, calculate the percentage mass of carbon, hydrogen and oxygen in this compound. The percentage mass of carbon is equals to, we have 9 mole of carbon here, then multiply 9 by the mass of the carbon and divide by the total molar mass of the compound, that is 180.159 gram. Then we will get the answer this. And then for hydrogen, multiply the molar mass of hydrogen by 8, that is 8 mole of hydrogen, and we will get 4.476%. Similarly for oxygen, 35.52%. This is how to calculate the mass percentage from the given mass and the using molar mass. Another is determining empirical formula. To determine empirical formula, what is empirical formula? Empirical formula is the simplest formula representing the lowest whole number ratio of atoms in a compound. It does not necessarily represent the actual number of atoms in a given molecule, but the molecular mass. The molecular formula is a formula that is the actual formula, and it actually represents the actual number of atoms in a given compound. And how can we calculate empirical formula or determine empirical formula? We have steps. The steps to determine the empirical formula. Step 1 is determine the masses of each element of each component of element. Step 2, convert the given mass into mole and write as a preliminary formula. Step 3, convert the given mole into whole number or integer subscripts and divide each subscript by smallest whole subscript, and if necessary multiply through by smallest integer that turns all the subscripts into the integers. Note that if the obtained mole ratio is a decimal that is greater than 0.1 or less than 0.9, should not be rounded off. Instead, we multiply by a small integer to obtain a whole number. For example, if the obtained decimal is 0.20, multiplier is 5, and 0.25 is multiplier is 4, and the like. But if the decimal is equals to 0.1 or 0.01 or 0.001, you can round off, and 0.09 you can round off to the next digit, and the like. For this you can do like this. So let me show you this with example determining the empirical formula from a given gram. Example 1, and you are asked to calculate the empirical formula. For this question, we have 6.87 gram of iron and 13.1 gram of chlorine. So determine the empirical formula for this. The answer is this one. Analyze the problem we have given, and we need to determine the empirical formula, connect it with the molar mass. Step 1 is calculate the moles of each element. by dividing the given mass by the molar mass. So mole of the iron becomes 6, the mole of the chlorine becomes 6. Step 2 is divide the smallest number of moles, the given ratio, to obtain the given ratio. So the smallest number of mole is 0.123. So divide this by 0.123 and for mole of chlorine by 0.12, and we will get this one. Step 3 is use the lowest whole number ratio of moles as a subscript. Since this is a whole number and this one ratio is not whole number, so change this into whole number. It is 0.01, so you can round off to the 3. And the empirical formula, the preliminary empirical formula is this, and after rounding of the ratio, it becomes iron trichloride. This is the empirical formula. Another example is the calculating the empirical formula from the percentage mass. In this case, we have to assume 100 grams of compound to express each mass of the percent directly as mass in gram. So let me explain this by example. Example 1, it says this: we have the given percentage of carbon, hydrogen and nitrogen, and the mass of the nicotine is 40.57. You are asked to calculate the empirical formula. So the answer for this is this one. The first step is set up or list out the elements in the compound. We have carbon, hydrogen and nitrogen, and change the given percentage of each element into gram. 74.02% of carbon is equal to 74.02 gram, and the like for hydrogen and for nitrogen. Step 3 is change the given mass into mole by dividing by its molar mass. The mole for carbon is equal to this one, the mole for hydrogen becomes this, and for nitrogen becomes this. Step 5 is divide by small whole number. The small number from this mole is this one, 1.233 is the smallest number. So divide this and this by the smallest number, and we will get the mole ratio 5:7 for hydrogen and 1 for nitrogen. So generally in this case we do not need to multiply by multiplier to change, because the obtained mole ratio is whole number. So the empirical formula becomes C5H7 and N1. This is example 1. Example 2 is this. We have this percent of carbon, percentage of hydrogen, percentage of oxygen. So you are asked to determine the empirical formula. Pause this video and try this by yourself, and the answer is this one. We have given percentage of each element, and we need to determine the empirical formula, and we can connect with the molar mass. So the first step is changing the given mass into mole by dividing its molar mass. The mole of carbon becomes this, the mole of hydrogen and the mole of oxygen becomes this. Step 2 is divide the obtained mole by the smallest mole. The smallest mole is 3.41 in this case. After dividing, the mole ratio of carbon is 1, the mole for hydrogen and the mole for oxygen is this one, and we have decimal mole ratio here. So change this into whole number, and you can a decimal that is greater than 0.1 and less than 0.1. It should not be rounded off, rather use a multiplier. Multiply this obtained mole ratio by 3 in order to change into whole number, and it becomes this one, and you can round it off 3.99, and the answer will be C3H4NO3. This is the way of calculating or determining the empirical formula. Another is determining the molecular formula. As I have told you, the molecular formula represents the actual formula. and we have some steps to determine the empirical formula. The first step is assume 100 gram of a compound to express each mass of the percentage directly as a mass. Step 2 is convert each mass into mole. Then derive the empirical formula and then divide the molar mass of the compound by the empirical formula mass to obtain the whole number, and then multiply each subscript in the empirical formula by the whole number. Finally, you will have the molecular formula. And determining the molecular formula, before going to determine the molecular formula, let me explain you the relationship between molecular formula and the empirical formula. The molecular formula is equals to the smallest integer times the empirical formula. Same, the empirical formula is this one, and the smallest number is n. If you multiply the empirical formula by a small integer, it becomes like this, and you can obtain the small integer by dividing molar mass of the compound by empirical formula mass. Example: our empirical formula is acetaldehyde CH2O, and if the integer for this is 1, and the molecular formula becomes this one, and model representation this. If our small integer is 2, the molecular formula becomes this one, and the model representation like this. If the integer is 3 and the molecular formula becomes this, when you multiply this by 3, it becomes this one, and the modular representation seems like this. And you can see for others, this is relationship between the empirical formula and the molecular formula. So how can we determine the molecular formula? Let me explain this by 3 examples. The first example is this one. In this, we have given the percentage of carbon, hydrogen, and nitrogen, and we have given that the molar mass of the molecular formula is 125 gram. You are asked to determine the molecular formula. So to do this, what we will do is use the mass percentage composition to obtain the empirical formula, and use the empirical formula to find the molecular formula, and the answer is this one we have given, and we need to find the molecular formula, connect it with the empirical formula. Step 1 is obtaining empirical formula. To obtain empirical formula, change the given mass into mole, and in step 2, divide the obtained mole by a small number, and write it as subscript, and then finally calculate the molar mass of the empirical formula. The molar mass for empirical formula is 42.05 gram, and step 2 is divide the molar mass by the empirical formula mass. The molar mass is 125 for the compound, and the empirical formula mass is 42.05, and the small integer becomes 2.93, changes into whole number, and you can round off this to 3, and the molecular formula becomes C3H6 and N2. This is one example. The second example is this one. Example 2 is given that the empirical formula is given C5H7, and the experimental molar mass of the compound is 135. You are asked to calculate the molar mass. How can you calculate this? Simply, the empirical formula is given, and you can calculate the empirical formula mass. We have 5 mole of carbon, 7 mole of hydrogen in this. So multiply the molar mass of carbon by 5, molar mass of the hydrogen by 7, and sum up the molar mass. The empirical formula mass equals to 67.11 gram. And then find the small integer by dividing molar mass of the compound by empirical formula mass of the compound. So the whole small integer becomes 2.01. So the obtained one is 0.01. You can round off to 2 and then multiply the empirical formula by 2. Our empirical formula C5H7 becomes C10H14. This is example 2. Example 3 is this. It says that, and we have given that the molar mass of the compound is 90.08 gram per mole, and it contains 40 gram mass by percent of carbon, 6.71 mass by hydrogen, and 53.3 percentage of oxygen. And you are asked to determine the empirical formula and the molecular formula. Then the answer for A is this one, determining the empirical formula. Then change the given mass into the mass percentage into given mass. We 40.0 gram of the percentage of the carbon is equals to 40.0 gram, and the similar for the others, and then convert each mass into mole. The mole of the carbon becomes 3.33, and for the other, for hydrogen 6.66, and for oxygen 3.33, and then divide it by small mole. Finally convert the obtained mole ratio into a small integer or whole integer, and the obtained ratio is this one. When you divide by smallest integer, that is smallest mole ratio, that is 3.33, it becomes C1, H2, and O1, and the empirical formula is this one. And the molecular formula becomes like this. First, obtain the small integer. To obtain a small integer, divide the molar mass of the compound by molar mass of the empirical formula. The molar mass of the compound is given, and the molar mass of the empirical formula can be obtained from the previous empirical formula, and we will get 3 small integer, and then multiply the empirical formula by small integer. So the molecular formula becomes 3C3H6 and O3. This is the way of calculating the molecular formula. Another is your activity. You have some activities to be done by yourself. The first activity is calculating the molar mass. You are asked to calculate the molar mass in each of the following compounds. The second activity is determining or calculating the mass percentage. So calculate the mass percentage for these compounds. And another activity is determining the empirical formula. You are asked to determine the empirical formula for this and this one. Activity 2, for determining empirical formula, you have given 3 activities here, and finally you have given the more challenging problem to calculate the empirical formula. So try to calculate or to determine this. Another one is determining empirical molecular formula. The first activity is this one, calculate the molecular formula for activities, this and these activities, and you are asked to calculate or to determine the molecular formula for more challenging questions. Here you have one question, and here you have another question. Thank you for watching today's video. See you next time in the coming video. The next video is about limiting and excess reactants. Thank you. Bye bye.